This is why I like the question. I like the question because you have to think about what direction is the friction force. So this is a kinetic friction force, so it always opposes the direction of the motion. So in this particular case, the friction force is back up the ramp, same magnitude, but this time it's up the ramp. And the weight force, you can't change the direction of that. The piece that's parallel to the ramp. Again, I'm only focusing on the parallel components, the only ones that matter. So this is the weight down the ramp. So this time you have to consider the net force is no longer a sum of those two. And it is technically a sum, but they're in opposite directions this time. Previously, they were in the same direction. So the F net on the block, in this case, is still the negative mg sine of theta, because again, I'm going to be consistent with my signs. But this time I'm going to have to add in the friction force of the mu k mg cosine of theta. So this time you're not going to get. So this was roughly 11 and this was 3. So that's we ended up in the previous case with a net force about 14ish. So now we're going to end up with a net force about 8. Actually, so it's 8 on the button. So the net force on the block is only 8 newtons down the ramp. Okay, so now friction's in the opposite direction. And from here, it's exactly the same problem now. Same strategy. So the acceleration of the block down the ramp, negative 8 newtons divided by the 2 kgs. It's just a negative 4. And then you would solve the problem again. So it's starting from rest at the top of the incline. So again, the final speed in this case will be equal to the square root of 2a delta x. So the square root of 2 times your 4 times again the 6.9 that we used previously. So if you think about where the negative signs go, it'll be a negative 4 times a negative 6.9. So you still get because you can't take the square root of a negative number. So this should leave you with 7.5. And then maybe I'll come back to this question when we do energy, and we could probably solve this a whole lot quicker when we have the energy tools, which we don't have yet, but we will. So again, it's a long question. So again, it's more of a bit of a teaching question, in addition to like a actual, maybe one of these parts could be valid.